Okay, now let's try to solve question 13. The question 13 seems very simple. It gives us a uniform distribution over the interval AB and asks whether mean and variance depend on the length of the distribution. The length of the distribution is nothing but length of the interval, that is B minus A. Well, if you just write down the formulae for mean and variance, it's rather plain to see that variance definitely depends on the length of the uniform distribution. But the question is whether mean depends. Now, to be honest, this question is rather ambiguous and there are many ways of interpreting this question. Many in the sense, at least two ways, where mean does depend on the interval or mean does not depend on the interval. Now let's suppose if we expand this interval slightly by epsilon on both sides, that is A minus epsilon and B plus epsilon. So if you define the uniform distribution on this interval, even though the interval has expanded, the mean stays the same, that is A plus B by 2. So this would prod us to conclude that mean does not depend on the interval. But if we consider something else, rather like A plus B, A comma B plus epsilon, then the mean would indeed depend on the length of the interval, which has slightly increased by epsilon, and therefore there will be consequent change in the mean. So hence there is no one way of answering this question. But I think the best answer here, even though not the right answer, would be the mean does not depend on the interval length, whereas the variance does. Okay. Let's try to understand and solve questions 14 and 15. These questions mainly concern the cumulative distribution function and its generalized inverse, which is the quantile function. And I say generalized inverse because the CDF may not always be a bijection between R and the closed interval 0 to 1. Now, let's take some arbitrary f which takes such a shape, which is discontinuous at some points. There is a jump of f at x and at this point. Now we know from the property of the CDF that f is always right continuous. So B being its generalized inverse would seem intuitively that B is left continuous, and it is indeed the case that B is left continuous. Now let's look at the question. The question says that there is a jump of the function f at the point x from A to C. That is, the f of x is C, whereas the left limit of the function x is A. Now let's try to see what's the value of B of C, the function B, at all the points between A and C. I claim that the function B is actually flat between B and C, and it's very easy to see by the definition of B itself. Now if you look at B of A, it will give us x. B being the smallest value, here the inf represents the infimum of the inverse of function f taken over all the values ranging from C to 1, C being the value at which the function is being equated. Now if you take a point A in the range of f, that is the domain of B, we'll see that B of A, and here A belongs to the interval 0 to 1. Actually A represents the value of probability, and probability is always between 0 and 1, including the values 0 and 1. So the B of A will be x, because x is the minimum value at which the cumulative distribution function f takes upon the value A. But take any p within A and C. What will happen? What will happen in this range if p belongs to here? Since the minimum value of x, which takes upon the value p, still remains x itself. Therefore, for all values of p within this range a and c, open interval, the value of b of p will be x itself, and it does not change. Therefore, the graph, if you draw a graph of the function b of c, which is a quantile function, it turns out to be flat whenever there is a jump in the CD of function at a point x. So therefore, the correct answer would be the option 4, which states that b is constant over the interval, open interval a to c. Now, coming to question 15, which is just a kind of converse for this question. It now states that the f is constant over an interval, say x to z. When f is constant, well, now it is, if you have understood the first part, it will be apparent that there will be jump in b, and that's the answer.